Hi, everybody. Welcome to today's webinar. My name is Julie, and I'm the Senior Director of Marketing Strategy here at Lumenalta. And I wanted to thank everybody for joining us here today. In case you are not aware of who Lumenalta is, we have been around since 2000, and Lumenalta has partnered with visionary leaders to reinvent businesses through technology. We enable AI outcomes through data modernization and application development for industry-defining use cases. Born from tech and not consulting, we deploy small senior teams in AI-first delivery to eliminate low-leverage work, accelerate execution, and deliver transparent, scalable outcomes that drive real innovation. Today, we have Donovan Crewe joining us. He is a senior software architect here at Lumenalta. And Donovan, I'll pass it off to you to present today's topic.
Cool. Thanks, Julie. And as Julie mentioned, senior software architect at Lumenalta. I've been around for 11 years or so and highly enthusiastic about AI and software delivery. So let me start with something a little bit uncomfortable. AI didn't remove the bottleneck in software delivery, it moved it. For the past 40 years, writing code was the constraint. Now, AI can generate code almost instantly, but the bottleneck didn't disappear. Right now, it's shifted to architectural decision, integration complexity, review cycles, and system-level coordination, which means something surprising is happening across many organizations. Developers are writing code faster than ever, but delivery velocity hasn't improved nearly as much as people expected. And that's because the real challenge isn't code generation. It's how the delivery system itself is structured. And that's what we're going to talk about today. So today we'll cover 4 things. First, what's happening across the software delivery lifecycle as AI adoption increases. Second, why context has become the critical missing layer. And third, how AtlusAI operating model works. And finally, how organizations typically begin applying these ideas in real delivery environments. Across the industry, we see the same pattern. AI adoption inside engineering teams has exploded. Most organizations now have Copilot, Claude Code, Cursor, or similar tools in place. Teams are experimenting. Productivity feels higher locally. And developers are writing code faster than ever. But when we take a step back and look at delivery outcomes, the picture is much less clear. Knowledge is still fragmented across tickets and documentation. Adoption varies widely across teams. Governance and risk concerns increase as code volume grows. And the most important issue is this. Software delivery is one of the most expensive and strategic systems inside modern organizations. Engineering is often a top 3 enterprise cost center. And the research shows that 20 to 40% of engineering effort goes to rework or defect remediation. Even small improvements in throughput can unlock enormous value here. So the question leaders are asking today is not, can AI generate code? We all know that it can. The real question is, why hasn't AI translated into measurable delivery acceleration yet? Where's my ROI? Research into agentic systems shows that something important. AI agents perform extremely well when tasks are structured and decomposed. But when coordination architecture is missing, performance actually declines. In some experiments, adding more agents without orchestration greatly reduces performance. When coordination exists, performance improves dramatically. The takeaway, scaling AI is not primarily a model problem. It's a coordination architecture problem. So if we pause here for a quick diagnostic, when teams adopt AI coding tools, one part of the process speeds up immediately. They can generate code instantaneously. But work usually slows down somewhere else. Across hundreds of engineering teams, we see 4 common bottlenecks. First is architectural bottleneck, where senior engineers become the constraint. Second is integration bottleneck, where work streams collide late in the pipeline. We have the review bottleneck next, which because we're generating code so quickly, the validation of that code slows down dramatically. And then lastly is the context bottleneck. Knowledge fragmentation slows down execution. If any of these feel familiar, the problem isn't the model. The problem is the delivery system around the model. Most organizations apply AI at the task level, things like code generation, test creation, or documentation drafting. But engineering delivery isn't just task execution, it's coordination across systems, teams, and decisions. And to scale AI reliably, 3 layers must exist. First is the task execution, then workflow coordination, and lastly is the shared context. Context includes architectural diagrams, dependency relationships, historical decisions, governance rules, etc. And without that context layer, AI delivers only incremental gains, which is why many organizations only see incremental productivity gains. But there's another important point. Context doesn't maintain itself. You're going back to being developers, systems evolve, documentation drifts, and decisions get lost. Maintenance of that documentation is very seldomly kept up to date. In AI native delivery, though, context has to be actively curated. Inside AtlusAI, we refer to this responsibility as the context gardener, someone that's responsible for maintaining the knowledge structure that the AI agents rely on. Because when the context stays accurate and structured, as so in general software development, AI can operate safely across the entire delivery lifecycle. This is a challenge that we set out to solve internally. At Lumenalta, we developed a delivery operating model called AtlusAI. AtlusAI isn't a code generator. It's not a standalone tool. It's a system for structuring context and coordination before execution begins. The model has 3 steps. First is direct. So senior engineers define architecture, intent, constraints, best practices, and this establishes the system boundaries that AI has to operate within. Second is dissect. Work is decomposed into parallelizable threads with clean interfaces and clear dependencies. This is the step that makes safe parallel execution possible. And lastly is delegate. AI agents execute bounded work streams, generating code, tests, documentation, and refactoring, while engineers orchestrate and review. So essentially, the role of an engineer changes. They move from writing every line of code to orchestrating delivery systems. And AI becomes the multiplier on execution capacity. Over time, we've codified this operating model into what we call the AtlusAI playbook. The playbook defines governance models, delivery workflows, AI-ready team roles, context engineering practices, etc. It ensures AI operates within architectural guardrails and not improvisation. So we're not vibe coding, we're directing. And this playbook is exactly how we run delivery internally. AI can now assist across nearly an entire software delivery cycle, from planning and design to coding, testing, and maintenance. But the important point is that AI doesn't replace human decision-making. Instead, it expands execution capacity while engineers retain control at key points, essentially leaving engineers to do what they're good at. AI can help draft designs, generate code, and automate testing, but humans still make the decisions that matter: architectural approvals, integration choices, release validation, and production oversight. So the goal of AI native delivery isn't removing engineers from the lifecycle, it's allowing them to focus on the highest level decisions, while AI accelerates that execution. For organizations who are thinking about this, the best place to start is not the tools. It's to understand the delivery system, to understand your delivery system. Firstly, identify where the real bottlenecks exist. Many teams discover that once AI accelerates coding, the constraint moves somewhere else. Architectural decisions, integration, reviews, context fragmentation, or generally up the C-level. Second, map how this actually works through SDLC. Most companies have varying SDLCs throughout multiple teams. And most organizations underestimate how many handoffs and dependencies exist between multiple teams and their SDLC. Thirdly, structure context before scaling AI, and make sure your architecture patterns, interfaces, contracts, governance rules, etc. are visible, structured, and documented. And finally, start with a bounded initiative. One project, one domain, measurable outcomes. And once the system proves itself, it's quite easy to expand. At Lumenalta, organizations usually engage with us for scenarios. So new digital project builds, modernization programs, feature acceleration, turnaround projects, and each one of these drastically benefit from introducing native delivery architecture. And then lastly, the biggest shift in software engineering isn't AI writing more code again. It's redesigning the delivery operating system so AI can the AI can scale safely across the entire organization. So that's the problem that's the problem that AtlusAI was built to solve. If this is something that your organization is exploring, we often help teams run short AI readiness assessments, or as mentioned before, full entire projects, to help point out where your SDLC can benefit from AI and how we can safely scale that across the entire system. And if that's something that will be useful to you, feel free to connect with us after this session. We'll be gladly open to discussing where we can move forward. And then before we wrap up, I know the chat's like a bit weird, and that was extremely quick. That my speaking went a hell of a lot quicker without being able to see people. But I guess we could open it up for any questions around, software delivery and context supporting software delivery.
Yeah. So there's a few questions, Donovan. The first one is, using this method, how do senior engineers operate differently day to day?
Well, you've shifted focus from delivering code to thinking the bigger picture, right? How are we architecting a specific system? How are you breaking down a task to be able to execute it across multiple work streams, across multiple agents, and deliver it as one piece of software? We often see that in cases, it might be easier for a single developer to see a feature from beginning to end, so that they could literally work front end, back end, mobile on a specific feature and dissect and delegate that throughout an entire AI orchestration model.
And the next one is, are there types of projects where they benefit most from this approach, or are there examples where this doesn't work?
In all honesty, I've seen really old projects that were badly documented benefit from documenting and introducing context-based engineering or agentic coding in them. And then I've seen greenfield projects which work just as well. In certain cases, governance is an issue, like PII data, but I mean, with the correct models and the correct contracts with your providers, they're definitely overcomable. So personally, I have not seen it not work well with anything. I've only seen benefit over multiple projects. I think, yeah, we've done 20, 30 projects this way, and it's all working great.
Talking about governance, another one is, what guardrails are in place to prevent hallucinations or incorrect outputs?
So, like that's an ongoing process, right? So that's where our context gardener comes into place. It's very similar to a Toyota factory line, and I hate comparing software delivery to a factory line because it should not be. But what happens in a Toyota factory line is, person A makes part A and passes it to person B, and at any point in that production line, if there's an issue with a specific part, they pull and think it's an adnan code, and the entire production line stops. And what they do is they go back to the source of where this problem started and they fix it quickly, and then they continue the production line. It's very similar in agentic coding where, hey, cool, you can continue writing, you can continue fighting with an agent or trying to restart a session again and getting the same result. But essentially gardening, keeping your context clean, keeping your prompts clean, keeping your guardrails clean is essential to like optimal delivery, right? So, I mean, basic guardrails are just structured like the way we structure projects, etc. But I mean, essentially that's a growing, continually evolving process of having these guardrails, preventing hallucinations, etc., providing too much context, providing too little context.
And how do you prevent context from being outdated or inconsistent?
Well, that's obviously our context gardening, right? So making sure that all our meetings are recorded, making sure that all Slack messages are in our context engine, making sure that all architectural documentation is in our context engine too. I think one of the biggest things is, as developers, we all claim that we've written tests and all claim that we document systems. Unfortunately, I doubt we're very good at both. Persisting that throughout agentic engineering or coding, yes, we can ask like, hey, can you keep the documentation up to date, as soon as you finish the session. But having a human curate a lot of that documentation or context that's coming into the engine drastically improves the quality of code and throughput that comes from these systems.
Excellent. I believe that is all of our questions. So, Donovan, thank you so much for walking us through this today. Again, as Donovan said, we'll be following up after this session with a copy of the recording. And if you have any more other questions or want to learn more, please don't hesitate to reach back out. Otherwise, thanks again for joining us, and we will see you in the next webinar.